Welcome, everybody, to the American Space Museum. I'm Mark Marquette, and we're so glad you joined us today to stay curious with David Mealie beside me, a young rocket engineer I can't wait to talk to. Hey, David.
How you doing, Mark?
Well, great to meet you. And, of course, we are very familiar with your company, Vaya Space, that we see behind here. That's not that show that they used to have on TV. That was kind of like X-Files. There was a series named V, I think, on there. Did you ever hear about that?
No, I have not.
Well, you'll be Googling that maybe afterwards. But no, Via Space, we're going to, there's some little bit of Easter egg in that logo there. Maybe you'll tell us about, David. But we've had Sean Mirsky on here. We've had two engineers. We had trying to think of Buzzy.
Yep, Buzzy and Evelyn.
Yeah, we're on here, and we had Rob Fabian on here, your boss. We're going to talk about all that in a while, but we've been wanting to get you young rocket engineers in here because we talk over and over that we're in the middle of a rocket renaissance like none other, started in the last century by the unmanned people that you met a gentleman here just a few minutes ago. Mr. Schmidt, that worked back there in our launch control. So we're anxious to hear about how Vaya Space is using recycled plastic to put about a ton payload in low Earth orbit, and this is your forte. David, tell us a little bit about yourself. Where did you grow up, and where'd your real dream of working on rockets come from?
Sure thing. I've got interesting answers to both of those. So I'm originally from New York, a little hamlet on the north shore of Long Island called Kings Park. It's a bit of a weird town because it actually gets its name from the abandoned mental asylum that surrounds the whole town that they built back in the 40s and 50s. So if you can imagine growing up playing kickball in recess, you just look up and there's a looming, like, Scooby-Doo looking tower right in front of you. That's sort of the vibe that I grew up in. But my journey really started at Rensselaer Polytechnic Institute. Which
you mean ghosts and spirits is the vibe? You're screaming people in the night is the vibe you grew up with?
a little spooky, a little goth, yeah.
I think we've seen something like that on some of these documentary shows or like that in there. But we're good. And that was, of course, you're right in your mid-20s, I would guess.
Oh, right on, 25.
All right, so like born in 1998. Last century, you can say, though, right?
Yep, I don't feel like a 90s kid either. But I don't feel like a Gen Z yet either.
Okay.
Sort of in that weird in between.
But where did you get into, are you an amateur astronomer? Did you like rockets? Anyone in the family work on the programs?
So my journey into space actually really got started, of all things, from video games. There's a little computer game that I know a lot of young enthusiastic space nerds play. It's called Kerbal Space Program.
Kerbal Space Program. Is that Kerbel?
Yes, it is.
That's for the Russian Kerbal science
yes,
thing they did on the mirror.
I actually don't know if that. I don't know if I've actually heard that before, but that would be just a really neat bit of space history. It was this game that was put together by a bunch of space nerds, and you basically build rockets for little green men to fly, and it's built with just fully realistic physics. And so, like, at some point in my college career, I just got obsessed with playing it and figuring out like the best ways to build rockets. And that sort of steered me in that direction.
That is very interesting. A video game inspired you in that. So we wanted to show just anything about growing up and looking back at the past. One thing about being a person your age, and my daughter's 27 years old, and she loves the rock and roll music that I grew up with.
Heck yeah.
And heck yeah, you like our music too?
I went through what I can only describe as a midlife crisis where I listened to nothing but Aerosmith way louder than I should have.
Okay, well that's a great example of Aerosmith. Okay, when their first album came out, and it's great, and then you had to wait like about a year and a half, 2 years for Toys in the Attic to come out. Their masterpiece, and you all can see the whole catalog. of any of these artists and listen to them all in one night, type of thing, where the anticipation was waiting for the next to come out, and there was very little information. And it parallels the space age and being a space geek and begging for more information about the Gemini flights in my youth, and then Apollo and so forth, where you literally had to go to the library to look at technical journals or aviation and space, weekly type of thing, because mom and dad weren't going to buy that for you, in there. So my point is that you have all this information at your touch, and we're going to talk a little bit about your education here. It's always a mystery to me, David, how they all put it together. How it's like drinking from a fire hose, type of thing.
That's the analogy. And an interesting statistic that I love to keep near and dear is the fact that during the Apollo program, the average age of those aerospace engineers was 25.
Absolutely.
It was a lot of very, very young, very curious minds just seeing this incredible program develop for their eyes and go, I want to be on that.
Yeah.
And it's problems that weren't solved before. And so you see these young minds, these young curious minds come in with just an entirely new perspective of how to approach and solve problems. And that's where you get all of this brilliance, all of this innovation so rapidly and so elegantly. And I love the fact that you see and I love the fact that you can look out at the aerospace industry, and especially Vaya, where the average age of our propulsion engineers is just about 25, and you see that mirroring of that curiosity.
And Marty Winkle, I'm giving you a shout out, my co-producer. And Marty and I have done this. This is our 845th episode of Stay Curious. And he was one of those mid-20s engineers out there, but he was taking us to the moon.
I wouldn't say mid-20s. I was 22.
Oh, listen to him there bragging about how young he was back then, 22. But same parallel, right, Marty? You were, but the only gray hairs wore suits, and you only saw them, once a month or something. Go ahead and talk on that USIAC family microphone there.
Yeah, there weren't very many gray hairs out there at the time.
Uh-huh.
I mean, there was some, of course, but very few.
Well, there still isn't today. I look at the control center of SpaceX when they out there in Hawthorne when they have that going on, and it's I like seeing the diversity of a lot of women, all right, and also all the ethnic things going on in there. And you certainly grew up in a melting pot in Long Island. Absolutely. Of things. Before joining Vaya Space, this young man went to Rensselaer Polytech Institute, and I didn't know anything about it, and you probably don't either, and I'm going to share the philosophy of this Rensselaer Polytech Institute. Their core values is the same as I see this rocket renaissance going on here. But tell us a little bit about, before you went to college, your forte, he's going to be telling us, David, is about Vortex hybrid rocket engines. Vortex hybrid rocket engines. That just sounds cool. Okay. But you played with rocket engines in your backyard.
Yes, my backyard at college, actually.
You described yourself as a controlled pyromaniac?
A high-functioning pyromaniac.
Okay. Okay. Good. Okay. Continue, young man.
Sure thing. So I guess, like I mentioned, I got my first spark, my first interest in aerospace, just from playing Kerbal Space Program as I was growing up through high school, middle school. But I think what really set me on the path that I'm on now was back in 2018, February 2018. I was in a course, Strengths of Materials in college, and it just happened to be the same date, the same time as the Falcon Heavy launch, the very first one. And so the professor stops what he's doing, puts it on, because it is, to be expected, one of the most monumental engineering feats that we're going to see that year. And so naturally, like, the launch goes off without a hitch, and much to SpaceX's sort of like, they weren't expecting this, but originally those two boosters were supposed to come down one after the other, but something went a little bit screwy, and they came down in parallel at the same time, and it was the most breathtaking moment. And it was in that moment that I realized, like, it's not just enough to be smart. You have to be driven, and you have to be passionate about what you do. And so that got me thinking, how can I like make my way in the space industry? How can I do some little project that would start me down that path? And so I bought a book. It's Rocket Propulsion Elements by George Sutton. And I read that thing like a Bible. I went straight through it, and I got the idea to build what's called a monopropellant thruster. This is a type of rocket engine that, instead of having a fuel or an oxidizer, has a special kind of chemical that'll decompose. And as it does so, it produces heat and expands, just like combustion. But because you only need one, I thought to myself, oh, it'll be simpler. And on the menu of different monopropellants, you've got chemicals like hydrazine, which is carcinogenic, volatile, explosive, toxic.
But used extensively in the space program.
Yes, I'm sure. Yeah, you're aware. And another one was hydrogen peroxide. And so I thought to myself, oh, if you can buy it at like a CVS, how bad could it be?
Yeah.
This was my first mistake.
Okay.
So I go through the process of designing this little, I still have a 3D print mock-up of it, this little monopropellant peroxide thruster. And I spend a good amount of time, good amount of money, like building up a little test stand for it. And before I start like buying the expensive things, I go, okay, well, I've got a professor here at this college who does propulsion. I should reach out to him and see what he thinks. And so I send that little email off and go to bed. And I woke up to a torrent of incredibly terrified, angry emails wanting to know what I was doing with peroxide, how I got a lab, and what I was doing.
Wow.
Because I didn't realize this at the time, but peroxide, what you get like CVS, is only 3%. And when you concentrate it up to 99%, that's what's called high test peroxide. And it is incredibly powerful, but also incredibly volatile. So any imperfections like dust, it can just detonate. And as it happened, that professor who I was talking to had an experience where he had just a little bit of it, just a couple of drops, detonate on him. And he lost hearing in one ear for a while. So I managed to talk my way out of that situation and not get expelled, fortunately. And after the dust settled, that one professor, a man by the name of Dr. Matt Oschlager, sort of sighs and goes, "You seem excited enough. So I'll let you work on a rocket engine, but just a rocket engine that can't explode." And I thought this was kind of crazy because I didn't think anything like that was possible.
Right.
And so he pointed me in the direction of hybrid rocket engines. And one of the other things is his background, Dr. Oschlager's, is from Stanford, where they're currently doing a lot of research into 3D printing energetic material, 3D printing fuel. And so he started me down the path, why don't you research 3D printing fuel for hybrid rocket engines? And as it happens, just by happenstance, there is a company right here in Brevard who does exactly the same thing. And the rest is history.
Interesting. Anybody else out there thinking of Sheldon Leonard and Big Bang Theory?
Oh no!
David Mealie here, the episode where he had trying to get nuclear stuff in there. But good for you. I think y'all get the hint out there that this is just one of the 60-some employees out there in our local rocket factory, Vaya Space. I was privileged I gave a cold call out there a couple of weeks ago. You answered the door, and I didn't know you till you came here today, put it together that you're the same one there. But we've had Rob Fabian on here, friend of our museum, your CEO or president. He was featured at our Shuttle Fest too last year,
Yes.
talking about Vaya Space. And it's a type of facility like none other. Yet I saw a rocket being spun out of 3D printer, out of plastic going there. And I also petted a few friendly dogs in this dog-friendly environment there. And it's just very interesting in a very positive way to see how these young people are taking this rocket renaissance in such a serious way, like you are, David. And let's get into that here, a little bit about the company, and then get into more of what you do as a rocket engineer. I wanted to brag about your. Let's see. I'm going backwards there, Marty. Let's see. We're okay. There we go. There we go. Now we're going good. There we got this handsome young man, David Mealie here, and. Is there any other people at Vaya Space that went to this Rensselaer?
Actually, yes.
Okay.
One of my good friends, Brian Deo, about a year ago, my advisor, he's my PhD advisor now, Dr. Matt Oschlager, reached out to me and said, "Hey, I have a brilliant young engineer here who's working on some exciting combustion stability research. I think you should talk to him." And so we talked, and it turned out that I sat right next to him in my fluid mechanics course.
Oh.
He's like like I was sitting right there, he was sitting right here, exactly next to each other, and we didn't know it. So we hit it off, and now he's a core member of the team. He runs a lot of our CFD simulations.
Well, I looked up this university because it is the oldest technological research university in America. Bachelor's, of course, bachelor's and master's you got from there. You're working on your doctorate, you said. The core values that define this Rensselaer experience, they say, these are the same words, Tom Usiak and Dave Stange, I know you're watching, that I associate with what's going on in our rocket renaissance. 1, groundbreaking technological advancements. 2, far-reaching intellectual exploration. And 3, a commitment to serving humanity. And if that's not the 3 values of Vaya Space and all these other companies out there, I think it's great to parallel that. And and there's many other institutions like this in America, though. You don't have to be from Ohio State, okay, but everybody has these core values, I think, as we're heading into the 21st century there. So let's just look a little bit more about the public relations for Vaya Space there. There's Rob Fabian, whose uncle, John Fabian, I've met a couple times at Kennedy Space Center because he was an astronaut. Particularly on the Sally Ride mission, STS-7. But say a little bit about Rob there and his leadership over the years.
Sure thing. So when I first joined the company back in 2020, he was originally the president, and as an intern starting at the time, I was terrified of him. He was Fabian.
There he is on Stay Curious a month ago.
I was actually listening to that very podcast on my drive over. But as time's gone on, I've gotten to know him. I've gotten to work with him closely, especially in these last 2 months, working on some special projects. And he's just such a wealth of knowledge in both technical expertise and in the history of like the development of space, both here at the Cape and throughout his time in the Air Force.
Yes, he is. He's also got a lot of humility about what he's done because he's probably signed all these non-disclosure agreements. Working on the MX missiles in the Midwest is one of his things. The silos that were full of solid rocket missiles for protection of our country. So go Google on our YouTube channel, Rob Fabian there, and you'll see we had a good conversation there. And he is so well connected, David. That's I think a real plus about Vaya Space. Tell us why I put that up there.
Dauntless?
Yeah, that's the name of your rocket.
Yes,
right?
It is. I've seen it every day. So Dauntless.
I looked up the definition there because I'm going dauntless. I think I know what it means. But according to Webster, showing fearlessness and determination. And this is your main look here. You're actually putting, instead of the fuel, you're putting the engines have the fuel.
Yes.
You don't have to have fuel tanks, is what I'm trying to say.
Absolutely.
But what dauntless? Did you have anything to do with naming it?
I did not, but I think for each member of the team and I have our own meaning for what Dauntless means to us.
Mm-hmm.
And I know me and my mentor, Kenia Wallace, we both view it as like, we do hybrid rocket engines, And for those who are first hearing the term or phrase hybrid rocket engine or vortex hybrid rocket engine, it might be kind of curious, like, oh, hybrid, like a Prius? Not quite.
Oh, right. Yeah, right. You're thinking,
So yeah,
okay.
so
Not old school and new school mixed, but
yep. So classically, when you have rocket propulsion, you have your solid rocket motors, where you have your fuel and oxidizer mixed together with some sort of binder and maybe a little bit of aluminum. And it's sort of what you see with firecrackers or like hobby rocket motors, where it's just a solid chunk, you light it up and it goes. Conversely, you've also got liquid bipropellant rockets. And this is what SpaceX uses. This is what all of the other startups for the most part are using, because it's incredibly controllable. You have two pumps. They're typically called turbo pumps. Not turbo as in not super powerful pump, but turbo meaning you have a turbine driving your pump. And this allows them to raise the pressure in the combustion chamber and flow all of the fuel as quickly and as efficiently as possible to produce thrust. The downside with this, of course, is that these turbo pumps are incredibly precise pieces of engineering. They're feats of engineering, each and every one of them. And so one of the hopes is, if you can eliminate your fuel or oxidizer from needing to have pumps, you can reduce the cost and complexity of your rocket engine. And so this is where the idea of a hybrid rocket engine comes in. So when we say hybrid, what we mean is that you have a liquid oxidizer, in our case, liquid oxygen, flowing over and reacting with a solid fuel. And this solid fuel is literally just a tube of recycled high-density polyethylene.
well, we're going to have you elaborate that a little bit more, but how articulate to set that up is we're going to share just two more things about the company here. And one, kind of importantly, is the leader is Sid Gutierrez, a shuttle pilot and then shuttle commander on 2 missions. And I've not met Sid, but I've read a lot about him. He's the first Hispanic to go to space, U.S.-born Hispanic. And as it all says there, know you've met Sid. Talk about, he has not bought into but believes this hybrid fuel technology that is truly going to change the landscape, I think, of rockets. Talk about an astronaut being at the top of the pyramid of Vaya Space.
Well, it's certainly a unique experience, I'll say that. And if I can, before I jump into that, a little bit of Vaya Space history is why the name Vaya. Well, because he is the first American-born Hispanic astronaut. Classically, what happens at Mission Control when you're counting down for launch, you'll say Godspeed to the crew. But of course, because Sid was mission commander, that launch, they said Vaya con Dios, which translates to go with God, essentially the same thing. And so that's where we chose to bring our name from. So it sort of calls back the history of Sid and his experience in the space industry. But to speak to Sid, he's an incredibly looming figure. He's an incredibly charismatic man. Every time he comes through, he always has stories for us. One time, I think we were talking about like foreign object debris. It's when you have something that isn't supposed to be there inside of a spacecraft. And so he was talking about a story where they were inspecting the wing of one of the space shuttles, and they found like one of their tools that a technician had forgotten inside the wing, and they'd sealed it up, and they were doing refurbishment on it, and the tool popped out, and they're like, "Oh no, this was in there the whole time." And it was just a really funny story, and he's full of just like an entire career's worth of experiences going to space and being involved with the human space program.
As Sid was pilot of one of the shuttles of June. We talk about the shuttles every month, this being June 30th. STS-40 was the second one launched in the month of June, had 3 ladies on board, and Sid was the pilot. They did life science. We had Mikey Haddad on our program the other day talking about that very mission on there, and he certainly worked with Sid. A lot of blood was drawn out of him on that mission, and then he was on STS-59, which was a radar mission, I believe. That was quite unique in mapping the world. SLS, I think, was that mission of his. But we always celebrate astronaut birthdays. When his comes around, we talk a lot about Sid and pioneering things that he did in space there. So, well, we want to get also just a quickie that here's the board of directors involved there with Sid on board. The Carroll Craig Industries there in the upper right, they were a big employer during the shuttle era. You've got, just get Grant Bigley, Ward Schrader, Kevin Loudermilk, and Leonardo Riera. And whether you know them or not, their little bio there, David, starts out with for 30 years, for 25 years, for 35 years, this person's been doing this and that. So the leadership, particularly when you add a couple generals there, where's those generals at? Did I put the generals in there? I think I did. No. Yeah, well, you got the leadership there. And then here's all your people. There's the two generals involved there. That's a good move.
Yep. Oh, for sure. That was it was excellent to be in the room when they started touring the facility, because you get into a conversation with them, and they spend all day talking to people. And so they're incredibly charismatic, incredibly approachable. And you just have that conversation, and you walk away and be like, who was it? Oh, that was a general. Oh. And it's really refreshing. It's really exciting to be to just explain sort of some of the exciting work that we're doing, because they're always interested to hear where technology is going.
Mm-hmm. Well, here's some of your colleagues and leaders there in management in different regions there, and Mary's right there in the middle there. Mary Baldino and Sean Mursky on the right. They've been on our show in support of our museum from the very beginning, and we're just looking forward to better things happening with Vaya Space here. And I'm going to let David tell us more about these hybrid engines as we go through these slides here that y'all provided of really, I'm not going to say the first green rocket, and they're not releasing any launch schedules yet, but you have the engines I know have been worked over for several years now on there. So we want to keep things proprietary and respect that with you is what I'm saying. But you do have a lot to tell us about eco-friendly, safe, and reliable.
Yes, I can. So I guess there's a couple elements of that. So I'll start with the very first, eco-friendly. So one of the beautiful things about hybrid engines is that you can produce a hybrid engine basically out of anything. It actually makes a really fun project. From my own personal thing. Yes, and if anything burns, you can turn it into a hybrid engine.
Okay.
In fact, you can turn wood into a hybrid engine. And that's sort of the mechanism by which it burns. To keep things at a rather high level, what happens is at the surface of the fuel, it sort of vaporizes that solid, and that vaporized particle will mix with the oxidizer and then react. And so, for instance, if you look really closely at a campfire, you'll see that the flame doesn't start at the wood, it started just above it. And it's that same phenomena that drives the combustion process in our engines. And I'm sure I'll dig into it a little bit later.
Yeah.
So that's to say that if you can get anything to burn, you can produce a hybrid engine with it. And so it happens, why not use recycled plastics? And it's sort of a good way to think about it is that when it comes down to the utilization of plastics here on Earth, you may have plastics and fuel for rockets. So if you think about RP-1, what happens is you pull that out of the ground, you refine it, and you send a rocket up with it. Whereas with us, we can recycle plastic that's already been through the carbon cycle And so it sort of mitigates our impact on the environments,
Mm-hmm.
which I think is just a beautiful way to utilize this technology.
Absolutely. As you alluded to, this, for example, SpaceX, the RP-1 is a kerosene, aviation kerosene type thing that they burn with oxygen, and same thing Saturn V burned on its first stage. So kerosene don't sound very high tech to me, David, as we're looking at one of the Vaya engines there burning up there.
Yes, that was our Comet engine. That was just before my time. And I can't speak to the merits of RP1. It's a particularly refined kerosene, because one of the things that a lot of engineers will do is, if you see that part where the fire's coming out, that's the nozzle. And because of course it has to contain the immense pressures and temperatures of combustion, you have to keep it cool somehow. That engine there is is using what's called an ablative. So that material has the very elegant caveman solution of bonk bonk, let it burn. And as it does so, it sort of creates that same sort of boundary layer effect, and it slows how much that burns away, so you can maintain a good position on your nozzle throughout the entire duration. But what SpaceX and what the vast majority of the aerospace industry does is they'll flow their fuel around their nozzle. And so because you're liquid cooling it, it means that you have the exact same nozzle geometry. The nozzle doesn't change. You're just keeping it cool, and you're pulling that energy, which would otherwise be waste heat, into the fuel. Of course, with SpaceX, one of the interesting elements is that as they do this, it has the tendency to polymerize. Those long chains of kerosene can sort of join onto one another and get even longer, and they turn into like a plastic. And so that's why it's RP1 and not just a kerosene, because you need to refine it very precisely to prevent that from happening. And this sort of leads me into one of the absolutely brilliant innovations that we have here at Vaya Space, which is how we run our engines. So our engines run off of an expander cycle. So one of the engineers that I have the absolute pleasure of working with every day is a man by the name of Sean Bowman. And he does design into regen channels. So what we'll do is we'll take our oxidizer, liquid oxygen, and flow that through our channels. And then as it expands, as it pulls in heat, we'll use that to run our turbo pumps. And that's a much more efficient way of producing work and pressurizing our propellants. So you can imagine it like sort of like the turbocharger on your car. You're using that waste heat to do some extra work to get a little more power out.
Well, David Mealie, you're doing an excellent job. I can follow all that, Marty. Or even I can follow that, Marty, is what I need to say in there. No, you're doing an awesome job of explaining this technology that these noisy rockets are flying off here all the time, and you're helping us understand a little bit more of why yours is going to be different. Here are the three stages. The first stage, of course, mostly designed to get everyone 20 miles up, right?
Yes, sir.
And that's where the atmospheres and gravity can allow a second stage just to boogie on up to where it's going, right?
Yes, sir.
And then you got your payload. So describe this as we look at the pictures that you provided here of your Dauntless rocket.
Yeah, so this version of the Dauntless rocket is our aspirational Block 2. It's going to be launching in 2026. We have two versions of our Dauntless that we're designing. We've got our Block 1, which is a two-stage, which is going to be capable of carrying payloads up to 500 kilograms into low Earth orbit, or LEO, as we call it in the aerospace industry.
Kilogram, 2.2 pounds, about a ton, or half a ton.
Yep, and then the rocket that we're looking at right here is our Dauntless Block 2 variant. And so this is going to be capable of carrying the full 1,000 kilograms up to orbit, and that uses a three-stage system, and that's going to be launching in 2026.
How tall are
Oh,
these two rockets about?
I don't know those numbers off the top of my head.
He works on the aft end. He doesn't know anything on the forward
That's where
end
the
there.
fire comes out.
Okay. It seemed to be 60 feet for your first one, and I could be wrong, but those are so here's the payload going to space.
Yes, sir. And it's actually a very interesting configuration, if I can speak to that.
Sure.
Because normally when you look at rockets, they all look very, very similar. They all look like cylindrical tubes, sort of like what Falcon 9 is, what SpaceX is flying. And ours sort of is a pretty big departure from that. We've got engines on the sides. And you sort of see that a little bit with Atlas V nowadays, where they'll use solid rocket boosters to give them a little extra kick into space. And that's not what we're doing. Those are actually our engines. So what we've got is our big oxidizer tank in the center, and we're pulling that oxidizer into our turbopumps and then send them up and down through those long hybrid engines. So you can think about it like we've got our big oxidizer tank in the middle, and each of those engines is also doubling as our fuel tanks. So all those around are engines.
Mm-hmm. So they don't have to be as massively tall.
They also, funny enough, are doing double duty. So they're not just engines, they're also our fuel tanks. They're doing both at the same time.
Yeah.
It saves a little bit of weight while they're at it.
And that's a second stage. No, that's your first stage version of the.
That's our second stage.
Okay. All right. Same engines on all stages, correct?
On block 2, we're going to be doing a smaller kick stage engine. But on block 1, we're doing same engines first and second stage.
Okay. And there's a separation with the payload there. Up there, that'll be a happy day, and we look forward to following this and keeping you apprised of this.
Me too.
Yeah, we're with David Mealie here. He's certainly articulate and sharing the great story of Vaya Space here, our hometown rocket company is how we tout this, David, because you truly are. In fact, I live in Port St. John, less than 3 miles from your facility there, so I can't wait to hear it in my backyard someday. I'm told that will happen. But we're going to get the home stretch here with you, David, talk about why launch with Vaya Space type of thing, and where are you going to be launching from? But is there something about I think you covered the hybrid engines there very well. We just can't drop our recycling plastic off your doorstep, though, right?
Please don't. So there's a couple things. I think what's the biggest element that gives us a competitive advantage is that it's not just a classical hybrid. We utilize what are called vortex hybrids. So you can imagine if you're spinning a tornado inside of your combustion chamber, that does a couple of really interesting things. The first and foremost is it creates a sort of centrifugal force which drives colder oxidizer into that flame, that boundary flame, and pulls that hot gas back to the center. And as you do this, you're constantly replenishing the flame, and you minimize how much your oxidizer to fuel ratio shifts over time. Because you can imagine, if it's burning just like any solid object, it's sort of like a candle. Like, imagine if I handed you a candle right here, and I asked, all right, blow on that until it burns out in exactly 3 hours and 36 minutes. But what we've been able to do through a lot of hard work, research, and a ton of math is figure out exactly how you need to blow on that candle to get it to perform exactly how you want.
That's very interesting. Good way to bring that up there. I think Tom Usiak understands that. Tom's our good friend in Lancaster, Pennsylvania. He was a shuttle photographer, covered over 70 shuttle launches with a Hasselblad camera and stuff. Doug Forrest is an artist in Los Angeles there. Speaking of it, hope everyone has a great 4th of July weekend. Robert Law's up in Dundee, Scotland, enjoying his Friday evening cocktail there. Cheers to you, Robert Law. Dave Stangy's up in Michigan. Carlton Bailey, I'll give you a call later, CB. He's one of our local rocket hounds out there. It's good to see Chris Boyd out at the Space Center when we were celebrating the 10th anniversary of the shuttle yesterday, Marty. Chris Boyd's one of the Space Hipsters administrators. So thanks for taking your time, Chris, to watch us. And we love Space Hipsters, and its founder, Emily Carney's been one of our guests here. Heather Erickson. You don't know Heather, do you?
I do not.
That's the name. Okay, I don't see any names here that I don't know except hers. Christopher Mick, he is eating this up because he's a STEAM educator in Hudson, Wisconsin, and also a solar system ambassador. And Bill Whiting wishes that he was old enough to be a STEAM or young enough to be a STEAM coordinator, and Solar System Ambassador, because he's a retired guy like me, Bill. Good to see you back on the Space Coast. We ought to get Bill behind the microphone here and share some of his Space Geek experiences. Well, as we're winding it up here, we really kind of got a surprise that we can tell you about Vaya Space, is where they're going to launch from. But first, they can custom tailor your launch. Actually, a 30-day from conception, if your payload's ready to launch, is what you're advertising, right?
That's correct. Going back to what I was saying earlier, one of the advantages that we have is a cost and complexity advantage, because you only need to worry about your oxidizer getting into your combustion chamber. It means that the number of parts is greatly reduced. And because we can 3D print our fuel grains, we can do that very, very rapidly. So we can put together a full Dauntless in 30 days.
The whole rocket's 3D printed, or a lot of it. How
Not
much?
quite. A good chunk.
I saw on your 3D spindles thing there a rocket being built. That was pretty cool the other day.
Oh, absolutely. So we've got our 3D printer. It's one of the largest 4-axis 3D printers in the world. We call it Prometheus.
Prometheus, okay.
And it's about 20 feet long and can produce the entire fuel grain for our hybrid engines as a single part. So on top of that, we've also got metal additive 3D printing. The technical term that the engineers use is powder bed fusion, where you'll use a laser over a bed of powderized metal to fuse all of your parts together. And so most of our fluid systems are made using that methodology. And as for the rest of it, we're using carbon fiber to bring it all together.
Very interesting out there. And it's basically a warehouse that you have sectioned off your propulsion, your all the things that you need there. And we'll take you behind the scenes there one day. I want to emphasize safe.
Yes. So
As opposed to using these liquid fuels. This is a pretty safe system, right, David?
yes, that's correct. You may have caught that I said that it's a rocket engine that can't explode. So I can sort of speak to how that works, because that sort of seems a little bit out of the ordinary.
Yes.
And so if you think about how explosions work, in order for something to explode, you need your fuel and oxidizer to mix in with one another. So if you can imagine about last month when they had the Starship launch, as it's coming down and it's falling apart, all the fuel and oxidizer are intermingling, and then it finds an ignition source, and then kaboom, right? But with a solid fuel, it's not actually possible to do that, because in order for explosion to happen, you have to mix the two together, and the only reaction that you can get is on that surface. The rest of the fuel is stored away inside the solid chunk, so it can burn on the surface, but it can never reach a point of explosivity.
Excellent explanation there. So, and the other thing we didn't talk too much about, I just mentioned that this is a very throttle. You can turn it off and on, which you
Yes.
can't do with the nasty solid rocket booster.
Yeah.
That's just like a Roman candle. These are not Roman candles or pop bottle rockets. You could turn them off and then back on, correct?
Yes, that's correct. One of the, like you were mentioning with solid rocket motors, because you have your fuel and oxidizer pre-mixed, it's a candle. You light it and it'll burn all the way out until all of the fuel is consumed. Which means it's incredibly simple to operate. It's how you've got, this is how like the space shuttle SRBs work. It's how hobby rockets work. But in terms of building a launch vehicle, it has some disadvantages, because when you're punching through the atmosphere, you'll tend to want to throttle down for what's called max Q, maximum dynamic pressure. And so this allows us to do that. All we have to do is change how we're injecting into the chamber and how much oxidizer we're injecting into the chamber. And as we change essentially how much we blow into the chamber and how hard we're blowing, we can tailor how quickly we're burning through our fuel, and that gets us our fine throttle control.
Excellent. I understand that. Interesting. So, so many things with Vaya Space there that is going to, they're going to get their share of the business. while we show you where they're going to launch from, before we do that, I've got a question, Marty.
Well, we had a question, except David just answered it.
Oh,
I was questioning the ability to throttle.
okay.
If
All
you'd
right.
like, I can even talk a little bit more on that because it's a classically
Who
difficult.
wants to know that?
Sure.
Oh, you did? Oh, okay. Yeah, Marty's who worked on the space shuttle main engines as a manager of computer stuff on there. Yeah, go ahead and talk about that.
Sure. So with throttle ability, it's actually one of the most historically problematic parts of a hybrid. Because, of course, if you've got there's no way to throttle a solid, so it's not even part of the discussion. But when it comes to something like a Falcon 9, all you need to do is the turbo pumps will have a little bit of a bypass, so you can throttle how hard you're running your pumps. And because you know how hard you're running your pumps, you know exactly how much fuel and oxidants are going into your chamber.
Mm-hmm.
But to bring it back to the candle analogy, you don't really have a one-to-one control over how much of that candle you're burning, classically. So there's two elements to it. The first element is that, of course, as you reduce how much fuel or oxidizer is going into your chamber, the first element is your pressure drops. The chamber pressure in which your combustion is occurring, because there's less combustion, the pressure drops a little bit. And so that reduces your thrust. And the second part is, with hybrids, how do you make sure you have the same fuel and oxidizer ratio? And classically, you really can't. But to bring it back to the many advantages of vortex hybrid engines, and I know it sounds a bit crazy that this one little advancement in technology has so many advantages, but because you can change how much vorticity you inject with independently of how much oxidizer is going into the chamber, it sort of divorces the two problems and allows you to solve them independently.
Excellent. I've got a question, David. What limits the size of a vortex engine? Can you get an F1 size engine out of this?
I'll have to show you after this, but technically, yes, you can.
Uh-huh.
It gets crazy.
Uh-huh.
So there are limitations to a certain extent, but the short answer is yes, you can build a hybrid engine at basically any scale. It's one of the unique capabilities of hybrids, and especially vortex hybrids, is its scalability. But to answer that question, one of the things that you have to consider when you design a hybrid engine is what's called packing efficiency. Because when you're building a rocket, you want most of the volume of that rocket to be fuel or oxidizer or serve some engineering purpose. But with a hybrid engine, you need to have a portion of your fuel grain. It's sort of a tube of plastic, and in the center you have a port that goes all the way down where your combustion occurs. And as you have more and more fuel flow, you need to make that port bigger and bigger. And so, as an actual joke, last year we decided to run our design algorithms with the test case of the F1 engine from the Saturn V.
Really? Okay.
And it turned out that the entire engine is wider. You could fit our Dauntless rocket inside the space of the F1 hybrid engine.
Amazing. That's interesting.
And it was really funny to just see like the exact nozzle contour of an F1. And you're like, yep, that's an F1. What is that on top of it? It was really funny. But you do run into limitations when you go incredibly large because of that packing efficiency. So it's an excellent resource for rockets that are small, reliable, and quick to produce and low cost to produce. Excellent.
I'm certainly enjoying this conversation, David, and I know our Stay Curious watchers out there are, and if we will have more Vaya Space people on here for sure, but where are they? And I just want to say, while I'm thinking about it, Murphy Haddad, or Mikey Haddad's watching, who's got a book over there on payloads there, and I'm sure he's enjoying the technical talk here. And David, you certainly are representing your company very, very well.
Thank you very much.
You are fun to have, and he's so articulate explaining this. So where are we going to launch these rockets from? Are we going to be able to see a Vaya Space rocket go up from Spaceview Park? Yes, we are.
Oh boy.
Yes, we are someday. This is Rocket Row, the famous, of course, Cape Canaveral, now Space Force, and that's Pad 36 in the foreground there, right at the tip where Blue Origin is going to launch. You're going to be about 5 rows down, about 5 pads down, so I'm going to be asking Rob, your boss, when they launch Blue Origin goes, can I hang out on your pad? But this is an aerial of it. Tell us what the pad number is and why we would know that.
So it's funny you mentioned that. So this pad is LC13, but you might better know it as Landing Zone 1 and 2.
That's right, right there.
And so...
and the red up from the point there is Landing Zone 1 and 2, because those are landing zones for
SpaceX Falcon 9.
Yeah, where you got turned on to that twin landing there.
So I can speak to that. So basically what happened was SpaceX's lease is up, and due to the rise in prevalence now of rockets with the capability to land themselves, NASA is in the process of shifting its doctrine towards a return to launch site, return to launch site capability. And when they say return to launch site, that means the exact pad.
Oh.
So they're pushing rockets to do more of what SpaceX does on Vandenberg's side of the U.S., where the rocket will launch out, and then 5-10 minutes later it comes back and lands right next to the pad. And so that's the direction that the industry is moving. And it was really funny because back when that was first announced, people were a little sort of like up in arms, being like, "Oh, how could they take SpaceX's pad?" Like, no, don't worry, SpaceX will have their pad. Don't worry. The funniest one was definitely, "Oh, they'll just work around SpaceX landing." Like, please don't make me do that. That's incredibly dangerous. OSHA would not approve. But there's 2 pads there. There's pad 1 and 2 on 13. And we're going to be sharing this pad with Phantom Aerospace and their Daytona rocket.
Phantom Aerospace, not the Phantom rockets that we're going to be buying this weekend for the 4th of July, right?
Oh, yeah.
It's a different company. Yeah, okay, good. Kind of similar idea. The
Similar scale rocket, but a fundamentally different architecture. They're going more along the Firefly SpaceX architecture of a liquid bipropellant.
Mm-hmm.
But because we're both using liquid oxygen, it makes our lives a little bit easier. That we can both use, that we can interchange pads and just use similar ground support equipment.
Well, one thing that amazes me, David, is we're ending this wonderful Stay Curious conversation with you and the company you represent well, Vaya Space, is that there are so many people want to put satellites into space right now, that I think Rob told me that your manifest is almost in the hundreds of launches that you're going to be part of. To speak to this industry of what kind of satellites do people want to put up, and there's thousands of them waiting to go.
So
Waiting for Vaya Space and other companies, like you said, Phantom, to get ready to put up these small toaster, from a size of a toaster to a microwave oven to a dishwasher, in what they call LEO, low Earth orbit. Define what low Earth orbit is altitude-wise, too.
So low Earth orbit is defined as starting basically around the Kármán line, which is 100 kilometers up,
62 miles.
And going up, I think up to 500 kilometers, thereabouts.
Okay, 300 miles, so.
Yep, and so to speak to that and the industry and its growth, one of the challenges that the space industry has always had is it's a chicken and the egg problem, because you can imagine, if the cost of a rocket's $200 million, well, who wants to pay that? We'll find some way to do the science here on Earth. But as SpaceX has brought launch costs down, it means that more and more companies can develop space technology. It's becoming more approachable. And one of the most beautiful elements of that, to me, is the democratization of space. When you see high schoolers developing little CubeSats college students developing little CubeSats to do research. One of my close friends was working on a project called Oscar, which would go up and collect space debris and deorbit it. And so because launch costs are coming down so much, it means that space is more approachable for more people. And that means that there is a much, much larger market available. And so because now there's a market developing, you can now see rockets coming to meet that demand. And so as more and more rockets, Dauntless, the Phantoms, Daytona, Firefly Alpha, SpaceX, Falcon 9, and Starship come into their own and really meet the demand, you're going to see that competition bring costs down, and you're going to see more people capable of accessing space.
Mm-hmm. Well, that's where the future lies, and that's why we have Future Fridays here on Stay Curious. David, is there anything I didn't ask you or something you'd like to share with our Stay Curious watchers out there, literally around the world?
Plenty of technobabble, but I'll hold that on my own.
Okay. Well, young man, you're certainly a fun person to be around. I'm going to show you around a couple of the other galleries here before you
Looking
leave
forward to it.
in there. But your initial impression of our museum?
It's incredibly breathtaking. Actually, I just thought of what I would have added.
Sure.
And it's sort of the beauty of one of the things I find so inspiring about the entire journey that the space industry has taken. And I was alluding to this earlier when I was saying that it was a bunch of 20-something-year-olds in the 60s figuring problems out for the first time. And one of the things that has really stood out to me in my journey is you'll look back at papers in the 60s and you realize, oh, they didn't have nearly the same resources that we did. We're standing on the shoulders of giants nowadays. What we can do is only so incredible because of all of these innovators who came before us. And definitely in my personal journey, it's the crazy amount of elegant solutions that people have come up with just math to incredibly difficult problems. And I find that inspiring, and it's what inspired me to pursue a doctorate in aerospace engineering. And just getting to see relics of that history here is truly breathtaking.
Well put. And you shook the hands of 84-year-old Don Schmidt, who worked on the Atlas rockets back there in our Cape Canaveral gallery. And thank you, David, for acknowledging the shoulders of these giants, men, women, from the secretaries to the rocket engineers. That's what we celebrate here at the American Space Museum. As we fondly say, when you're in our museum, you're in the delivery room of the birth of America's space age. And you and Vaya Space and all your wonderful people there are taking us to the heights we never ever thought about. And we just wish we'd get more people on the moon and towards Mars. But we'll do that with young people like you out there. Marty, thank you for a wonderful Streamlabs engineering job today. We want to tell everybody that we will be not back with Stay Curious until next Wednesday, July 5th, as we're going to take the extended break with the holiday being on Tuesday. And so go to YouTube and look up some of the programs that we have on there. Over 300 Stay Curious episodes on YouTube. The rest of them are on Facebook on there. So we thank Vaya Space for participating the way they do with our American Space Museum here. And we thank you all for enjoying Future Fridays on Stay Curious. And until then, everyone have a safe 4th of July. And until next week, thank you, David.
Thank you, Mark.
Thank you. Until next week, I'm Mark Marquette saying we can't wait to see you again to bridge the space between us.